Very good morning student. This is the lecture of object oriented programming using C++. We have already started our third unit, that is extending classes using inheritance. In this today's session we will see the last subpoint of this unit and the two last units of the third unit, that is the abstract class and derived class constructor. In the previous session we have seen the virtual base class, and in the today's session we will see the abstract class. So what is abstract classes? A class that contains at least one pure virtual function is said to be abstract. So first of all, what is the pure virtual function means? A pure virtual function is a member function declared in an abstract class but defined in a derived class. So we know that inheritance means we can create new class or derived class from the existing one. So what is abstract class? In that class we can only declare the member function, but if we want to define that function, we have to define that function into the derived class. So if we want to write the definition for that function, we can write this function of the definition into the derived class, not in the abstract class. So it is known as the abstract class. Okay, a class that contains at least one pure virtual function is said to be abstract. An abstract class does not create any object and it contains one or more functions for which there is no definition. So we cannot create the object of the abstract class. Why? Because it is an abstract class. It is only used to declare a function, not to define the function. And in the abstract class we can declare one or more functions. A class used only for the deriving other classes is called the abstract class. Means this class is only used as a base class and it is used to derive other classes. An abstract class is designed only to act as a base class, that is to be inherited by other classes. It is a design concept in program development and provides a base upon which other classes are built. This is only a for the designing of the program, means it is only for the it is only working as a base class. So there is no any definition of the function into that class. A class containing a pure virtual function is called as an abstract class. It is called abstract because we cannot define objects of a class containing a pure virtual function. So why it is called as an abstract? Because we cannot define object of a class containing a pure virtual function. So it is exists only for the purpose of defining classes which are derived from it. We can create pointers and references to an abstract class. This allows abstract classes to support runtime polymorphism, which depends upon base class pointers and references to select the proper virtual function. An abstract class is used only to derive other classes. For example, shape is abstract base class which derives square, circle and rectangle. So when we declare shape as a base class, there is no any function definition into that shape class, but we can define pure virtual function into that shape class. Suppose calculate area is a pure virtual function, so we can just write the definition of that calculate area function, not the definition. If you want to define this function, we can define it into the square, that is a derived class, that is a square class, circle class and rectangle class. In this case, shape is a abstract base class and all these three are the derived classes. To clearly understand the concept of abstract class, we will see one program. So see here, class shape. Now class shape is an abstract class. So it has a protected member, that is a float L. It has one function, that is a void get C in L. So by using this get data function, we can take input from the user for the length. Now here is a virtual function, that is a pure virtual function. How to define a virtual function? We have to use virtual keyword for this, after that data type of that function, and now name of that function. So virtual float calculate area equal to 0. First we have to define this function and initialize by 0. This is the exit of that or end of the shape class. Now class square circle, these both are the derived classes which are derived from the class shape, that is the abstract class shape. So class square colon public shape. Now in the public section, here see here it is a virtual float calculate area. No any definition is written here. Now here is a definition of that function calculate area. So float calculate area in bracket written L into L. So what is the formula of calculating square? Is a length into length. Okay, so this is the definition of that function. Now in the class circle, see here class circle colon public shape, this circle derived class is also derived from the abstract class shape, and into this float calculate area, again this pure virtual function is used into the circle class, but here the definition of the calculate area is different than the square. Why? Because calculating area of the circle is a is pi r square, so 3.14 into L into L. So see here the same, it has both the derived class has the same function, that is a calculate area, but definition of that function is different. Why? Because in the abstract class here we are not defining that function, just we have declaring that function. By using this is called as a polymorphism, means same name of the function but definition is different. So abstract classes support for the polymorphism. Now in the main class we cannot create the object of the abstract class, so here we are creating two objects, that is S is the object of square and C is the object of circle class. Now first enter length to calculate the area of a square. For that we are using the S dot get data function. This will take the value for the L from the user. Now area of square is equal to S dot calculate area. Now S dot means it is object of square, so it will first call this function. So length into length is the answer of the calculate area. Again in the next enter radius to calculate the area of a circle. Again here by using the object of circle class we are calling this get data function. Here we can get the value for the L as a radius of the circle. Now by using the C dot calculate area means this function. Now by using the 3.14 into L square function we can get the area of the circle. So what is the output of this program is enter length. First user enter the value 4 for the length, so 4 into 4 is 16, and next for the radius 5 into 5 into 3.14 is a 78.5. This is the abstract class. What is the main thing to remember in this class is abstract class has one or more pure virtual function, and in the abstract class we can only declare function. We cannot create object of that abstract class. Okay, it is only working as a base class and we can derive different classes by using the abstract class. So we will see the next point, that is a constructors in derived classes. So there are two major questions that arises relative to constructors when inheritance is involved. First, when are base class and derived class constructor and destructor functions called? So we already know what is the constructor and destructors. So constructor has the same name as the class name, destructor is also same name as the class name by preceding tilde operator. So constructor, it is automatically called when you create a class and create the objects. So in the inheritance we have one question, that is when are base class and derived class constructor and destructor functions are called. So second question is how can parameters be passed to base class constructor function. So as long as no base class constructor takes any argument, suppose means in a base class constructor, if suppose there is no any argument, so no need of to write constructor function in the derived class. But if a base class contains a constructor with one or more arguments, then it is mandatory for a derived class to have a constructor pass the arguments to the base class constructor. Means what is that? If your base class constructor don't take any arguments, in that case we need not declare or use the constructor function in the derived class. But in our base class constructor, if it has one or more arguments, then it's compulsory for the derived class to have a constructor and pass the arguments. When a class is declared, a constructor is also declared inside the class in order to initialize data member. So when we declare any class, the constructor is automatically declared and it initializes the data members. It is not possible to use a single constructor for more classes. Why? Because constructor name is the same as a class name. So we cannot use same constructor for the multiple classes. Every class has its own constructor with a similar name as the class. When a class is derived from another class, it is possible to define a constructor in the derived class, and the data members of both base and derived classes can be initialized. Means what? In the derived classes, we can create the constructor, and by using that derived class constructor, we can initialize all the members of the base class also and derived class also. So it is not essential to declare a constructor in a base class. Thus, the constructor of the derived class works for its base class. Such constructors are called a constructor in the derived class or common constructor. Means suppose we have one base class, and by using that base class we have derived one derived class, and in the derived class we can write the constructor, and by using that constructor we can initialize both the values of base class and derived class. That type of constructors is known as the constructors in derived class or common constructor. So there are two types, there are two main points, that is the order of calling constructor. So what is the order to call the constructor? Means which constructor call first or which is later, and second is the passing parameter to the base class constructor. So when both, first we will see the order of calling constructor. When both the derived and base classes contain constructor, means suppose in the base class and derived class they both have the constructors, then base class constructor is executed first, and then the constructor is the derived class is executed. In case of multiple and multi-level inheritance, base classes are constructed in order in which they appear in the declaration of the derived class. So when we call the constructor, first the constructor of the base class will be executed, and then constructor of the derived class is executed. Second is the passing parameter to the base class constructor. So in case where derived class constructor requires one or more parameters, we simply use standard parameterized syntax. The constructor of the derived class receives the entire list of arguments with their values and passes them to the base constructor. Now we will see the syntax of the derived class constructor. So see here, derived constructor, first argument 1 to up to argument n are the argument of the base class, and this argument d, now this is the body of the derived class. In above syntax, base 1 through base n are the name of the base classes inherited by derived class. Colon separate the derived class constructor declaration from base class specification, and base class specifications are separated from each other by comma. Means this is the argument of the base class 1, this is the argument of the second class, like that. These all arguments of the base classes are separated by comma, and the colon which is used to separate the derived class. Now we will see one program. Here class alpha, in that integer x is a private member, alpha I, this function is a public. into that x equal to I, means we are assigning value of I to the x, and after that we are displaying one sentence that is alpha is initialized. In the show function we are displaying the value of the x. Same like beta, float y, beta, in that y is equal to j. Again here we are using the beta initialized. Again show function is used to display the value of y. Now in the gamma, gamma is the derived class which is derived from the beta and alpha class. So private integer n and m, and in the public class integer a. Now gamma is the constructor of the derived class. So first integer a, so argument of the beta class is passed, then argument of the public class is passed, then these are the integer a and integer d are the argument of the class gamma. Now alpha a and alpha b, these are two functions. Now m is equal to c, means this m is equal to c and n is equal to d. These are the argument of the derived class, that is a gamma. A is the argument of the class beta, sorry alpha, and float b is the argument of the class beta. Now gamma is initialized by using the show mn function. We are displaying the value of n and m. Now in the integer function here, gamma, it will pass 4 arguments, total 4 arguments, 5, 7.65, 30, 100. This 5 is assigned to the variable which is declared in the class A. This is for class B, and these two are for the class A means alpha, beta, and these two for the gamma. Now here we are displaying the first show dot x, so it will display the beta initialized, alpha initialized, then gamma initialized, and after that it will show the values of the number. So this is nothing but the constructor in the derived class. Here we have completed our third chapter, that is inheritance. In the next session we will start our fourth chapter. So here we have completed extending classes using inheritance.